Good morning guys, this is Aidan again. Welcome back to my channel. Yes, good morning to all motorsport, car owners, petrol heads, whoever that's in the car community. This video is for you. Okay, today where I'm gonna be going is a place called RDS, Radical Dynamic Solutions. These guys are one of the top suspension specialists you can find in the country. Not only they do servicing, but also fabrication, as in custom absorbers for just about any car. So the reason I'm gonna be visiting them is because the current set I have in my car that was actually customized by another fabricator is not up to my liking. It's the shocks are acting funny, and it's got a very funny characteristic to it, as in it feels like it's got too much rebound, or perhaps too much gas, or the spring rates are too hard. So I'm gonna be finding out what's wrong and do the necessary do whatever that is necessary, because as far as I'm concerned, I've been trying to communicate with the previous fabricators, the previous guys, and I don't know, maybe they're not listening, or they just can't give me what I want, or they cannot understand what I want. Yeah, previously in the past video I did mention on having a car being set up to a driver's driving style, or having a driver adapting to how the car was built in terms of suspension, and I just can't seem to hit a sweet spot. Yeah, the car is bouncing everywhere. It's too hard. Even on the highway, on the freeway, it's just a little bit too stiff to my liking. It's supposed to be more plush than this, even if it's gonna be having minimal body roll in tight corners and whatnot. So let's see what RDS has to offer. Okay, so we arrive at RDS. Yep, there's a small banner there. Let's just go in and say hi to Aiden, and let's see what he has inside the shop. There's a damper room here, a so-called clean room, tons of calculations.
Hey bro.
Say hi.
Hi bro, morning.
Morning.
Welcome.
So just
Yeah.
okay. Thank you. So what we see here is what Aiden does is he has several types of setups for customers, from single-way dampers to two-way, three-way, four-way damper. And what's on this table here is actually a two-way damper where you can actually adjust it. Okay, let's just let Aiden do the explanation.
Hi. So basically, this two-way canister allows you to adjust the low speed damping and high speed damping. There are about 20 clicks on the low speed and 5 clicks on the high speed. Yeah. This set has a solid mount on the top and on the bottom.
So each solid top mount is custom made by you guys, right?
Yeah. Designed by ourselves and machined with our partner that we liaise with.
I assume it's as solid as it can ever be.
Yes, every set is very robust. We use only the best quality for maximum safety. Yeah.
Okay, so is that an external canister, reservoir for extra oil?
Yep. This reservoir basically allows you to have more oil inside the absorber, Conventionally or traditionally, inside this absorber without the canister, a portion of it would have gas. So some of the benefits of having more air, more oil is that you have a more consistent damping over long periods of time. So say if you're doing long-term hard driving, that it does give you more cooling, so you have consistent damping over a period of time, and it does make your general damping curve more linear compared to the traditional style where the floating piston sits inside the absorber.
Okay, so fluid temperature affects viscosity and damping.
Yep.
Makes sense.
Yep, including volume as well. With the volume, we can mess around with the ramp up and ramp down rate of the damping.
Okay.
Yeah.
And do you have any 3-way or 4-way here?
3-way is our top of the line. We do have one still in the process of fabrication.
Oh, interesting.
Yeah. So basically, this is also running. We'll be running our solid mounts.
Okay.
We're also currently doing a new style of mounting for the absorbers.
What in the world is that?
This is a adjuster body.
Okay.
For the 3-way.
Okay.
Basically, the 3-way has an adjuster on the piston rod, so that's how it becomes a 3-way. We have 2 ways here, and the 3rd way is here.
Oh, okay.
Yeah, so this will attach onto here.
So what is the 3rd way?
The 3rd way is basically bleed, or more commonly known as for people as the rebound control.
Rebound.
Yep.
Okay.
So you have your low speed for damping, high speed damping, and your rebound.
Okay, so this is in the midst of building.
Yeah.
What car is it for?
It's for an RX-7.
RX-7.
Yeah.
The yellow one is outside.
Yeah. We sent it back.
Oh, okay. All right. Thank you for the quick explanation. So we'll come back to you guys shortly. Okay, and we are back. So, Aiden, perhaps you can elaborate on your SOP when a customer comes in, either for damper servicing or maybe customizing a new set and whatnot. So, in terms of having to do the necessary calculations, motion ratio, yada yada yada, to get a spring rate, and yeah, I'll let you do the talking.
Alright, sure, thanks. So basically, we'll run by the servicing first lah. That's more common, and I guess that's what we prepare people for most. Basically, if say someone approaches us with an issue of like the damping, or maybe there's a sound in the car, a very harsh knocking sound, or just generally as a driver they feel that the car does not perform as it used to perform or it should perform. So when the customer comes in, we will first and foremost test the car, get a rough baseline for how the vehicle performs, and at the same time try to replicate, see if it's a noise issue, when the noise occurs, where it happens, how often it happens, what it sounds like, what it could be. Start building up a list of what could be wrong, some shortcomings, how the car handles, how it copes with the changes in direction, the body roll, all that. We do a basic evaluation. Then the car comes in, we jack it up, inspect what we need to inspect, what we feel, whether there's anything wrong, if the absorbers, whether they are really leaking. Say a customer says, oh, the absorber might be leaking. So yeah, we just have a basic look around and advise the customer and proceed on with what we need to do. So basically we'll remove the absorbers from the car and start tearing them down. And throughout the whole process, if we do find out any updates, if the customer's with us, we will update them right away, or through WhatsApp or messages, just basically liaise with them, update them what's the progress, what's going on, what we found was wrong, what the suggestions are, what the options are, if any. Then next would be, say if a customer or someone wants a new set. Car comes in, We jack it up, put it on weighing scales to get the weight of the car with the driver, and if desired, with the amount of passengers that they're looking at intending to carry. Sometimes they do bring those extra people they're carrying, or we do have a baseline through calculation to compensate for the extra weightage and load. So once the weight has been calculated, we then remove one side of fronts and one side of rears and begin the measurement of the absorbers, so that we can make up our design, see what we can change, check the clearances, and then measure the geometry of the car. If it's a car that's been done, then we'll just basically weigh the car and check out the design. Usually the geometry is the same. But if it's a new car, then yes, we do have to get the geometry of the vehicle. What's its motion ratio, how the damper moves to the arm, where it's its sitting position, what angle it sits at. And then we measure the current spring rate of the vehicle, and with all this data we put it into our computer. Nowadays we have worked out a calculator to do it for us, which basically we put in all the parameters, and it will help us direct us in the right direction. And then finally we proceed with the fabrication and the valving, all that's required.
Okay, thank you, Aiden. So just a quick question. If a customer comes in saying that he wants a certain spring rate, let's say a 12K, 14K, or perhaps an 8K for a certain type of vehicle, do you actually allow that? Do you encourage, do you discourage, and do you recommend, or do you not recommend that at all?
Basically, for us, first and foremost, we would ask what is their intentions of using that spring rate. Are they running a very low ride height, whereby they need the spring rate to hold the vehicle up, or whether they're intending to do some track driving, like really hard performance track driving, then maybe it would be possible we would go along with their plans and their intentions. Otherwise, we also have to look at what vehicle it is being applied on, what car is using the 12K. If it's on a car with a double wishbone, at times, and with the correct rate, it is possible to use that spring rate. But say for example, if it's sitting on a Proton Saga with 12Ks or Myvi, that is a bit too extreme for the road, whereby it does put the driver into a dangerous situation whereby they can hop off the road through the skips and bumps.
Yeah, bounce off the road.
Yeah, or the common thing we see as well is like in Subarus, yeah, they do tend to run very high spring rates, and they do have a case of skipping off the road quite often.
Okay, thank you very much for the explanation, Aiden. So I believe Aiden is he's gonna test drive the Mazda, get the feel of it, and he'll be driving the car straight into the shop and to hoist it up and get work started. So Thank you.
Thank you.
Okay, so Aiden's gonna be heading for a test drive, and no, I won't be following, and let's just give him the car key and let him do his stuff. Okay, so how does the car actually feel?
Actually doesn't feel too bad. Probably maybe just that the oil has been degraded over time. So it does have the characteristic of it being under depth. This isn't so bad at the low speed conditions, but as when you pick up speed a bit more, it does start to lose its damping and its holding power. And there are some weird creaks and squeaks from the absorber at times, some knocks, maybe some deal bush is worn out. Yeah.
Old car.
Yeah, but not too bad, still quite okay.
Okay, so we don't know if another mechanic is here. So you don't know if the spring rates are too hard or not until you do the proper calculations, right?
Either that, yeah. But generally based on the basic evaluation, it doesn't seem too far off. It could be managed, but possibly we might lower it. Yeah.
All right. Thank you very much. So this is the master of the workshop, Kenneth. Say hi.
Hello.
Yes.
Good morning.
So Kenneth will be working on the car alongside Aiden, and I think we can do a hyperlapse on this. So be right back, guys. Okay, so what Aiden and Kenneth will be doing is to actually remove the current shocks from the car. Let's just call it brand X, okay? So Aiden mentioned that brand X runs on a lot of gas, which causes uncontrollable and a very high rebound rate, and he needs to sort that out. He has to machine a new gas valve into brand X shocks, and that will probably take some time. It's already the weekend, and it might take a few days. So what I did is that I have my original stock standard shocks with me, which will be installed onto the car just so that I can bring the car home either overnight or for the weekend. Well, the last thing we want is the car having to stay here over the weekend and I'm gonna be carless. So they're gonna be removing the shocks, and what's coming up next will be a hyperlapse video on work being done in terms of shock replacement. So currently the shocks are out of the car. What Aiden gonna be doing is to actually disassemble each and every shock for inspection and servicing, and also revolving. Earlier in his explanation, he also did take measurements of the vehicle in terms of motion ratio and travel and everything. So as per what you can see, he's a very clean and neat guy, so he washes every component before it's being brought into the damper room before inspection. There he is. Is he coming in? Nope. I think he's gonna bring some tools in shortly. So you can see a wild Aiden in his natural habitat, measuring and measuring and measuring A to Z, making sure everything is according to what he has in mind. So he's opening up the spring. Okay, let's see what is he up to next. A wild Aiden in his natural habitat. Yeah, he's a very tedious guy. So as you can see, he's a founder and he's a brain of RDS, whereas Kenneth is the sound of the guns outside. He's the muscle of RDS, so he's the one doing all the heavy lifting, whereas Aiden is actually the architect, the one that does all the planning and whatnot. So each and every shot has a marking at the bottom here. He's going to be disassembling the shot. It might require a little bit of drilling according to what he mentioned off the camera just now, as I did mention that certain brands are actually running on very high pressure gas and whatnot, so not all brands are the same. The good thing about Aiden is that he's able to accommodate to various kinds of manufacture, and he knows what needs to be done and what cannot be done. So tedious as usual, making sure everything is well lubricated. Yeah, feel free to say whatever you want.
Right now we're opening the body sheet to get it back straight to the basic shock tube. We've recorded down the preload and the body sheet height so that we can set it back. Normally if nothing's being changed, then it's just a pure service. So we'll retain back the values.
Record.
Oh, record.
Yeah, it's nice and cool inside here.
Has to be.
Today is public holiday and no double pay, but hello.
It's giving, but slowly.
There's a bit of muscles. There's a bit stuff.
Yeah, it's been stuck, hasn't it?
Okay.
So yeah, when it gets stuck, then we might have to use. And fantastic.
Yeah, so for shocks that's been on the car for an extended amount of time, a little bit of brute force is needed. As per what I mentioned, Kenneth is actually the muscle of the workshop, and things get done. Right.
Yep. Sometimes you just need that. Just get to the bottom. We will have to drill for the Titans. We would have to drill the tube. No issue whatsoever. We use a different type of casing.
So where will you be machining the valve?
Usually at the bottom.
Okay.
The path where we try not to put it along the side, because when you put it at the side, then when the floating piston moves down, depending on where it is, there is a risk of it damaging your oil seals. Yeah, basically the O-rings, you can tear it. Yeah. So we drill it at the bottom. It just already has a gas valve. This is different for a Titan. It already has a gas valve, so we do not need to make a gas valve. It's good news for you.
Good.
fantastic, so we probably can get things done quicker.
Yeah, which kinda. So we're now kind of thinking whether we put the old shocks back in the car already, just because we thought that machining was actually needed. So things might be able to be done in a single day or something. Don't know.
Most likely, depending. We'll see how things are when we open them.
See how lah.
Yes.
Oh, there's a gas bulb.
Yep.
How much gas do you think they're running?
15 and above, I suppose. That seems to be normal. But maybe wrong. Special tool for it. Rubber grease, not to damage the rubber.
Or it's the same method of releasing compared to other shocks.
Yep. Surprisingly, this is an uncommon. Wow. 11 bars. That's quite alright. So that's recorded again, so that we can retain it back to how it is in case some customers desire. Alright. Now to release the gas, manual needle. We do change our needles from time to time. We have a whole stock of it. Yeah, it's important to change the needle because when it gets blunt, then it can damage the gas valve. Hand of die. So these are aluminium chucks. They generally won't damage the threads on your body because the body is steel. Yep. So we can clamp it without worrying about it damaging the threads, and you can't screw in the body shaft, and we can get a solid grip on it. This can be difficult at times, but it's not bad.
So yeah, nobody bothers you in front of the camera. It can get very casual, right?
Yeah. Has this been opened before?
Yes.
This is a bit different.
What does that clip hold?
This circlip is the one thing which holds everything together inside the absorber. It holds the guide, which has the main seal and the dew bush. The main seal is inside the guide, so that's how everything gets kept inside. You need the circlip to prevent the gas pressure kicking it back out. Yeah. Fun stuff will happen, like okay, we don't have it anymore. But yeah, we used to have like a couple of showers.
No holes in the ceiling.
Yeah, no holes in the ceiling here. Yeah. So yeah, basically that's what the circlip does. Holds everything together so that it doesn't get big bunch of mess in your OEM dampers. Yeah, basically there is a circlip still, but it's welded off at the top. It's not so accessible.
Okay, so what we are doing now is to actually remove whatever oil there is in the shock absorber. If you see anything abnormal, yeah, just say it out loud. It's fine.
For now, it's just mainly that the oil is quite dirty. Yeah, it's definitely smells a bit funky. So for those of you who are watching, unfortunately you can't smell it, but it smells pretty funky. Yeah. Alright, so now there's just one more component left to take out, which is the floating piston. It's inside here.
Are the seals okay?
Seems fine. I mean, when we
no leakage.
No leakage, so that's the first good sign. At the top, there was a bit of marks here, but I'm not sure if that's from the outside.
Okay.
Yeah, this seal is a bit crushed, so that I'm not too sure why it's like that. Yeah. But aside from that, everything else still looks good.
So, what do you think of the valving and whatnot?
Well, if we were to look at this, it does seem a bit short on the compression side. Like it does lack a bit, and of course, I think you were mentioning that no matter how much you tightened up the clicker, it felt a bit loose. And I was talking about the bypass when we were consulting.
So, can we conclude that the absorbers were relying too much on the spring?
Yep.
I'll go and see what's wrong. Okay, let's just continue doing it.
Sure. So we're just looking at the valving in the sense that they are skipping some. If you look carefully,
You can bring it closer to the.
alright.
Yeah, just.
Yeah, if you look closely here, you can notice this from the bigger shim. It sizes down. This is about a standard, maybe like say for example a 32, and then it goes to a 28 or something like that. So there is some progression, but then over here there's a loss. There's emptiness, so usually there should be some amount. So, but that's purely depending on the top valving, and as you can see at the top valving here, from very large to another smaller one here. So they skipped one shim here in the progression, but they probably did it to soften up the initial compression. But so at times it can that would be why sometimes you do feel a bit of looseness and lightness, because there's no progression, there's no holding.
Okay, so some of you might not know what we are talking about. Perhaps you have one that's properly built with the shims on it, proper shims. I think I saw one the other day.
This is actually another brand, but what one we say where the valving is more complete and progressive. This is a bit extreme because this is for a track car. As you can see, it's very thick on the rebound, right? Yep. But even here, there's a whole progression. You can see everything.
So you can see the shims going up in even sizes.
Yeah, in a pyramid stack.
It looks like a mountain, like a pyramid. Okay.
So this would be your compression. As the absorber moves down, the shims would want to bend this way upwards. So that's where the resistive force comes from and where your damping comes from. And then on the rebound, it pulls back up. So, yeah.
oil travel pushing the shims resistance. Alright. Okay, so what's next for the current shocks? Based on calculations, revolve, what's going to be done?
I think we maintain the 12 feet. It's based on the motion ratio, everything is quite correct. It's just the valving has to be increased a bit.
Okay.
Just trying to see if we can actually use the shims. You may be in luck.
Kenneth in the background. So when people say every time you remove your absorber, your alignment runs off, that's not actually the case here, where Kenneth can actually retain whatever camber and toe during disassembly and assembly. It's a matter of knowing how to do it and how to do it right. So for every time Kenneth takes an absorber out of a car and puts it back, you don't actually have to send it back for alignment. Right.
Yep, that is true. Yeah, as long as you can bring it back to what it was set at. And like for the rears, there's not much holding it, especially yours. The fronts are double wishbones, so whatever we do to the absorber doesn't really affect the alignment.
Okay.
Aside, unless of course we change the ride height in your case, like if we decide to change the spring rate, it goes, we change the spring, just change the spring rate. The height will change, then your alignment will change. Other than that, yeah, it shouldn't run. Usually for the McPherson struts, yes, they can run, but as long as you can mark the exact location precisely and set it back, yeah, no issues at all.
Thank you.
Be right back.
So as you saw Kenneth and his gun at in the background, kung krang, that's what he was actually doing, getting his marking done right, and just doing whatever that's necessary. Yeah, if you think you can get it done in a day, then don't bother swapping out.
See how? The rears I'm not sure, so the front maybe can, but yeah.
Take it out and see.
Oh, kasihan kita. Kasihan kita.
So as per what Aiden mentioned, the vice has an aluminium grip on it. It has an aluminium clamp to avoid damage on the shaft. Very important. You don't want a scratch shaft or warp shaft that causes any leakage or any weird movement or whatsoever. So you think the piston jet no problem? The bleeder hole not too wide?
There's nothing much we can do about that anyways, because yeah, that's by them.
Is that a problem?
To an extent, yes, because if you're already bypassing so much oil, there's only so much we can do to try and reduce that. Yeah.
Stack the hell out of this.
Yeah. Now we move here, and if we will try to measure the current valving, and then we'll work it out what to change.
Do I move the camera there?
You can if you want. Yeah, it's a bit messy there.
So Aiden is actually measuring each and every shim's diameter. Microphone is facing me, so he won't be talking much to you guys. For your information, he's an engineer graduate from a local university. Oops. So for each and every shim he's adding in regards to both the top and the bottom of the rods, it will affect both damping and compression one way or the other. The more shims added, the higher the damping, as in the harder the absorbers will be. And as per what he mentioned, he wants it to be progressive. It's because he wants a very smooth plush movement, no shortcuts taken during the process of measurement and of course inspection and reassembly. Just to take note that we are working on the front absorbers first. Calculations on the rear absorbers are totally different, and it's gonna be back to square one, which I don't think we will be recording. So once he is done with the measurement, everything will be put back together with new oil. If the seals are broken, the seals has to be replaced and whatnot. So there is nothing much to see here. It's gonna be time consuming, probably 10-15. How long do you normally take to measure?
Measure this.
Yeah. Yeah, it's a 10-15 minute process to actually get the measurements right after calculations, adding, subtracting nuts, you know. So I'm gonna cut this part short. Okay, so Aiden is going to be reassembling one of the shock absorbers shortly. What he has done is thorough inspection and replacement of one or two leaky O-rings, as air was actually escaping into the, gas was escaping into the oil chamber. So after inspection, replacement and shimming has been done, he's gonna start the assembly right now.
Okay, so yeah, first of all, this is the shims now. Quite a big difference.
Focuses. There's a nice mountain there you can see right here. Okay.
Alright, so first thing, measure the tube. See how long we have to work with.
How long you have to work with, as in, to determine the oil volume or what?
Yeah, basically the oil volume to air pocket, air chamber spacing. We normally try to push as much oil as possible, not to like cut cost or whatever. So yeah.
Is the more oil the better?
Yep. more oil gives you a better damping curve because yeah, the oil basically is the main part of your valving. The gas is mainly to prevent cavitation. At the most, help a last minute prevent the bottoming out at times. With the high pressure, it reaches a certain point, a kickback point. So yeah, good. That's in.
So the piece that you just put in, is that what's separating the gas and oil?
Yeah, that's
Okay.
the floating piston, as we would call it.
So you push it all the way as low as possible.
Yeah, to more or less what I calculated here. In this case, I worked it out to about 135 mm.
Why not lower?
Any lower than, under certain conditions, the floating piston can bottom out. Though it's quite rare in the sense that if that happens, there's nowhere else for the air to go, so it'll most likely blow into the other side or out. But basically, you don't want there to be a situation where the floating piston bottoms down, or this hits the floating piston. So that can cause like weird sounds, weird damping. Yeah. So oil done. I mean, floating piston set. Oil.
So for your information, Aiden is using one of the best fork and suspension fluid in the market from Fuchs, Fuchs. Good temperature retention, yada yada yada. You know, the normal things on what you get is good ATF and engine oils. Yeah, no need to describe much in oil. Oil is oil, cool, protect, lubricate.
So now we're bleeding the system a bit in a way, making sure that all the oil passes through the hollow rod, the jetting, and this properly product oil flow through the piston. So just popping it off.
Yeah, soft hard absorbers are actually hollow in the center of the rod.
Not enough. Oh, bunch of holes there. So good enough.
How do you know if it's enough or not?
Mainly for us, once the oil starts flowing out like that,
Okay.
right, we try to get it all around so that we know all the bubbles are out, so there's no chance for cavitation, or at least no air bubbles when we close it up. So it's a completely closed system.
So in short, cavitation will cause a ton of problems. You never know what sort of problem, right?
Yeah, in the sense that first and foremost is that you lose all sense of damping. If ever there's a scenario where there's air pocket here, usually it'll be up here, but as the piston moves on, for some reason there's an air pocket here, when it comes to this point, it'll be completely empty and your absorber will just crash down. So usually what happens is air at the top. So sometimes for certain cars, it may feel like the initial compression is completely empty and then you feel something, or during the rebound it just boom. You do tend to hear, usually there is a hard knocking noise.
Okay.
Yeah, very harsh noise inside the cabin. And then you cause the oil to boil over because there's a space for it to actually begin to boil over. Basically the same rules of cavitation always apply, so that's why we always try to remove it.
To boil over.
Yep, with the pocket of air, it makes it much easier to boil over.
Okay.
a clip in. Always have to make sure it's in before you try to fill up the gas. Right now I'm doing this one thing, which you only tend to do on sets like this. It's just to make sure that the floating piston is seated, and I need to cap off the top first because this seals are pressed from the top. If you fill up gas, it can shoot out. So yeah, just gotta make sure it's down. Once this is down, tighten, and then fill up the gas.
What kind of gas do you normally use?
We use nitrogen, in the sense that it's inert, it's a normal gas, so it doesn't react. It is less prone to temperature changes. So same thing like why race cars use nitrogen in their tires and whatnot. You get a consistent pressure throughout the whole duration.
Do most suspension absorber manufacturers use nitrogen?
Naturally, yes. It's a rather industry standard. So yeah, we just have to make sure that it's all the way down so that we push the floating piston down to its lowest point, so that we maximize, yeah, like I said, one is we don't want normal air to be in there, so we try to pump it out as much as we can. There are instances where you can vacuum it out if you're really picky. We don't. So there is a bit of oxygen, air, but not too much. Generally doesn't change the readings too much. So just a bit.
So that's a nitrogen fill valve.
Yep.
He's checking if it's too much or too little pressure.
Checking for leaks at the gas valve. No bubbles. It's a good sign.
Yep.
Off.
And we are done.
Alright, so after revolving, just as a way to test, not the proper way to test, but just a rough idea to see whether there are any noticeable changes, would be to compress the absorber. So this is the one that we just did. So this I can just push down much faster without any stop, and pull up much easier. This is the old one. This is the one that we just did. Takes a lot more effort to push down and to pull up as well. Yeah. So in short, we did increase some rebound damping and compression gain.
So in terms of rebound, the objective of servicing the shocks today was to actually improve or increase or decrease rebound.
In this case, it would be to basically, in this case we decided to increase it because in the sense that it was going a bit too out of control. The frequency is too high.
So for every time the absorber cord presses, it rebounds up too fast based on the old setup. The new setup will actually improve whatever that's happening previously. Right.
Yeah, it should. In theory, it should, based on what we checked on calculator.
Okay, cool. So we can proceed with other shots as well.
Alright.
So while Aiden is away washing the absorbers one more time prior to installation, let me just show you around what's in his workshop. So as you can see, there are various kinds of tools to actually open up the absorbers. There are plenty of circuit pliers, tools to remove the spring seat, you know, vice grips, pliers, and certain sockets here, and a common ring. So as I mentioned earlier just now, only the best oil is used to fill up the absorbers. Fush, two different weights, 2.5, 7.5 viscosity, and of course some red line for spare usage. So a couple of other used absorbers or customers absorbers, I'm not sure what the hell are these for. Springs, and of course there are a couple of turbos here, as Kenneth does his work at night on customers' cars. He's pretty well versed into turbochargers, and you see a bunch of snails here, they all belong to Kenneth. So each and every green bucket is ongoing. They are all ongoing jobs, as they are waiting for parts, waiting for bushes to be machined out, and some of them customers have not yet brought their car back here for fitment. So like I mentioned, each and every basket different customer. So KW suspension, what car is this for?
This is for 997.
Yeah, it's for a Porsche 997, probably some expensive shit, right? Let's go see the meeting area. So you see a million drawers here. That's where he keeps all his shims. This is his workbench. So heading to the office area, the meeting area, you will see a lot more stuff like various kinds of springs of different brands, and I think the bronze ones up there are Swift springs. These are very famous spring makers. So again, there are a couple of other random items like gas masks, wires, hoses. They also do custom jobs such as end links, spherical bearings for your undercarriage or lower arm, custom engine mounting. So these guys are engineers, and if they cannot find something in the market, they'll just get one fabricated. These are where all his valves are. Cover for the extra oil canister, bushes, washers, and that's pretty much all about it. So Aiden is back reassembling the shocks again, and it's gonna be fitted in the car.